Hi, everybody. This is Mr. Sweeney with Math Bridge, and we are going to get started here. Hopefully, you have a good picture of my whiteboard. Okay, good. All right, and then we're going to. That's a little bit better. Okay, get some outside light going on here. Okay, sorry about that. Let's see. There we go. Okay, so a few things. I was waiting for a couple students to join, but that's might happen in a little while, and that's okay. So we're going to do a few things, and what we're going to do is we're going to go over kind of like some word problems, linear equations, word problems that are based off of linear equations, okay? And that is an assignment that I have posted today, and that is due Friday, okay? So I'm going to get started with a couple of examples. Okay, so like the example, in the work that I've sent you, there is an example that I'm going to go through first, and then we'll do a couple more to make sure everybody understands it. Okay, so we have examples like we went over this in class. When you have kind of like a club, or a membership, and they charge you a one-time initiation fee. And then after that fee, they charge you a cost that is reoccurring every month or week or whatever. Okay, this could be this could apply to something like you buy a cell phone and then they charge you like 5 cents a minute or whatever that is. So there's a fixed cost. All right, and then an additional cost as time goes on for each unit. Like a week would be a unit, a day would be a unit, things of that nature. Renting one CD at a time would be a unit. So we're going to go and we have our example here is the Bowlodrome. Okay, so the Bowlodrome bowling alley, all right, has 2 memberships, okay? And the first membership is the Gutter Club. And the Gutter Club is, they charge a one-time fee, okay? So it's a one-time fee, which is $36. Okay. And then what they do is they charge you $4 for every additional game you bowl, okay? So the $36 is a fixed cost, okay? That's a fixed cost. And it's a one-time fixed cost. And we'll say it's a one-time fee. So it's a one-time fee. So then what they're saying is like if you want to go and you want to bowl a game, it's $4 every time you bowl a game. So you've paid $36 just to join the club, but it hasn't even included any bowling yet. Okay, so it's an initiation fee. It's a one-time fee. So if you were to graph this, on a graph, right here would be like $36. And that's the y-axis. So you start right here, okay? So notice when X, this is X, right? These would be number of games of bowling. So at 0 games, you haven't bowled one game yet, and they've charged you $36 just to join the club with no bowling yet. So then they say, okay, I'd love to bowl a game. Like, okay, so at one game, so we'll plug this in. Y is my total cost. This is total cost. Y equals, now they're charging us $4 a game. So we'd say $4 right, times X plus 36. So our linear equation is Y equals 4X plus 36. That's a linear equation, right? And look, the 36 is on the y-axis. When something's on the y-axis, look, that means x is 0. So if I plugged in 0 here, 4 times 0 plus 36, y would be 36. All right, that's the total cost, $36, but you haven't bowled. So I'm going to say I'm going to bowl one game. So we're going to plug this in. We have y equals 4 times 1 plus 36. And 4 times 1 is 4, plus 36 would be $40. $40 would be my total cost. That one game of $4 plus the fixed one-time fee of $36 is $40. So your first point right here with no games would be 0, 36. Now I'm going to bowl one game, and this is y, this is x, and this is y, and y is our total cost, right? Y is our total cost. So at one game, 1 times 4 is 4, plus 36 is 40. And then the second game, I'm going to play 2 games, right? And then 2, it'd be 4 times 2 plus 36. That's 8 plus 36 would be 44. And then that would be another point on the graph. 1 be 40, right? This would be 42, right? Would be 44. And that's our slope. Y equals 4x plus 36. This is my y-intercept, right? And a slope is $4. And x is how many times you bowl, right? And so there you have it. You have that. Now, we have the other club, at the other bowling club is a little different. The strike club, okay, is going to be, let's see if I can do this. I'll do it over here. Do it on this side a little bit. And the strike club is going to be the strike club is another bowling club, right, at the Bowlodrome. And the difference is they have a one-time fee that's only $10. So we have y is equal to, right now, the fixed cost is $10, right? But what are they going to charge us for a game? Oh, I see. That's how they get you. Now it's $6. It's $6 a game. So it's y equals 6 times x plus 10. So down here, so we have y equals 6x plus 10. And that's the other linear equation we're dealing with. Okay? It's cheaper to join this club initially because it's only $10. But then they're charging you $6 a game. Whereas over here, it costs more to join the club, but it was less dollars per game. Okay? So I'm going to make a prediction that because we're charging you more, the strike club's charging you more per game, and this is less per game, Eventually, right now this looks like a better deal because it's only $6 game, only $10. So you bowl one game. Guess what? One game times 6 is $6 plus 10, and that's only $16. Where remember the other one we bowled one game and it was $40. So what we're going to do now, we're going to graph this, and we say my y-intercept is 10. So that's probably going to be down here. That's 10, right? And then it's $6 a game. So at one game, that would be 6 plus 10 would be, so now you're up to here, 16. That's 16 is my total cost. That's my y. So we have x's and y's, right? The first one would be 0. I'm just to join 0, 10, and there's the point. 0, 10 is right here on the y-intercept. 10 is my y-axis. I'm sorry, 10 is my y-intercept. So now we're going to play bowl one game. One game is 1 times 6 is 6 plus 10 is 16. So that's another point on our graph. 1, 16. And what's going to happen is I predict they will eventually cross because the slopes are different. 6x, 4x, slope of 6, slope of 4. It's a different slope. It's a steeper slope. The 6 is a steeper slope than 4, but it starts lower down. So eventually you're going to have some sort of intersection, right? And now we're going to go back to what we did before we took this crazy break, and we're going to kind of like make a determination of when is both of these clubs, when do they cost the same amount of money? Okay, there's going to be an amount of games that amount of games you can bowl, right? Regardless of the our y-intercept, regardless of the initiation fee or membership fee, okay? And there's going to be a magic number that says, hey, when you bowl X amount of games, it's going to cost the same amount of money to be in this club. Then the next game, one club's going to be a better deal. So it's like, oh, I want to join club. I don't know which club I should join. It's like, well, how much do you intend to bowl? If you intend to bowl a lot, then something with a smaller slope, a cheaper game, will be a better deal because the difference between 4 and 6, right, is 2. And the difference between 36 and 10 is 26, right? So eventually, that difference of 26 will be gobbled up by the difference in the price per game or the slope. So let's erase this, okay? And we're going to find out exactly when we're going to find out the number of games we can bowl that equate or make both memberships cost the same amount of money, okay? So I'm going to erase this real quick. I'm going to leave up our linear equations because they're going to come into play right here. And I'm going to rewrite everything. And I'm going to show you what we got here. We have this. We have y equals 4x plus 36. And then here we have y equals 6x plus 10. Now, the question we have is how many games can we bowl that will end up costing the same amount of money, where both plans will break even, and you'll have the same amount of money to pay for that amount of games bowled. Okay. So what we have here, we have y equals 4x plus 36, y equals 6x plus 10. So what we're going to do is, here we have this y and this y. Okay. Now, what we're going to do is we're going to substitute this y for that. I'm going to rewrite this. So I have 4x plus 36 is equal to, because instead of having the y equal to 6x plus 10, instead of having that y, we've substituted this y for this expression. Okay. So now what we do, and we could graph this if we had a graph, and sometimes you'll have a test or a quiz or an assessment where you don't have a graph and you don't have those nice neat squares, and you just plot your y-intercept and just go gradually, and then you have your ruler, and then you plot the other one, and you're like, oh, it meets right here, that's great. And if you don't draw a nice line, or if you're a little inaccurate with where you put the dot and drew that line, you're going to get an approximate answer. This is an ironclad way. It's a foolproof way to find out that break-even point where the two lines cross, right? Where that one value of x makes them both equal. Okay, so this is a way to do it without graphing. Okay, so what we're going to do here is we know that it's $4 a game, right? And then it's $36 to join. And then this one was $6 a game, and it's $10 to join. Okay, so we've set them equal to each other, and now we just do like a backtracking. Okay, backtracking is doing the opposite of what is of the operation that is happening in the expression, and then you isolate a variable and you find out, you determine that value of x. And here we go. So what we're going to do is 4x here, 6x here. I don't like negative numbers generally. I'd rather deal with positive numbers. Okay, so there's more over here, there's less over here, so I'll subtract the 4x from both sides. Minus 4x, minus 4x. Okay, now I'm going to rewrite this. That is gone. And so I'm keeping it equal by doing the same thing to both sides of the equal sign. So now I have 36 is equal to 2x plus 10. All right. Now, there's some magic number multiplied by 2 plus 10 gives you 36. And it might not pop into your mind real quick. So we're going to do some backtracking. So it says plus 10, subtract 10. Minus 10, minus 10. Now I have 36 minus 10 is 26. 26, right? Equals 2x. Now, 2x means 2 times the value of x. So the opposite of multiplication, 2 times x, would be division. So divide 2x by the coefficient, which is the number in front of x. Divide this by 2. Also, to keep these equal, you have to divide the 26 by 2. So I'm going to divide them both by 2. Okay, and that gives me x, that's gone. And I know from experience that 26 divided into little chunks of 2 will give you 13 chunks, right? So you're saying how many times is 2 going to 26? I'm going to take 26 and break it down into pieces of 2, and you get 13 pieces of 2. So 13 times 2 is 26, and there you have it. Now you're like, wow, 13 games. And you're like, okay, I think I did the math right? It seems right? I'm pretty sure. I wish there was a way I could guarantee my work was perfect. Is there a way to check this work? And let's see. I know that if I substitute 13 for x, into both the equations, that might be a nice way to figure out if my math is correct and if I have indeed arrived at the correct answer. So what I'll do is wherever my x is, I'm going to plug in a 13. So here we have 4x. We have 4. That was my x. Now I'm going to plug in 13. Plus 36. Let's find out what this equals. Okay. 4 times 13, I know 4 times 10 is 40. 4 times 3 is 12. 12 plus 40 is 52. 4 times 13 is 52. Then I have to add that to the quantity of 36, right? And I know 6 plus 2 is 8. Nothing to carry. And 3 plus 5 is also 8. So now we're saying that y equals 88, and that would be my total cost if I did the Gutter Club and I bowled 13 games. It would cost me $88, and that's great. Now I know it's $88 to bowl 13 games, but that's part of what I was looking for. But the other part is it the same for this? Because we're saying that it doesn't matter what at this point. At the point of bowling 13 games, the first thing I told you was like, we're going to find out where both of these memberships equal the same thing. Okay, and let's find out. So my other equation was, I'm going to erase some of this. And my other equation was the 6x plus 10. So I'm going to write 6, and this is where I'm going to plug in my x right down here, plus 10. Okay, so we said 13 is my x. I'm going to plug in 13 here. Okay, plus 10. So we have 6 times 3, I know is 18. I carry my 1. 6 times 1 is 6 plus 1 is 7. So 6 times 13 is 78. Now we're going to add it to 10 to get our sum. And 10 plus 78, I'll tell you right now, is 88. Oh wow, look at that. It works. So if I do the Strike Club, with a greater slope, but a smaller y-intercept or fixed cost membership fee, and I bowl 13 games, which I just proved, 13 games times 6 is 78, plus my initial one-time fee of 10, 10 plus 78 is 88. It's the same thing as a lesser slope, but a larger y-intercept if my x value is 13. And I proved it right here. We said 4 times 13 was 52, plus 36 was 88. So right here, and this is exactly what it's going to be. If you were to graph, this is not going to be a perfect graph, but if you were to graph, right, and you had your graph right here, and you said x is 13, so we'd say, like, this would be like 1, 2, 3, ... 13, and you went up to 88 up here on the money y-axis, you'd have something like right here. And even though one started at 36 up here, and one started at 10 down here, because the slope was steeper, that's going to go up quicker. And this slope starts at 36, my y-intercept, right? This slope is not as steep, so it's still going to rise, just not as quick. And that would be, your solution would be 1388. x, when x is 13, y was 88. And that makes both of these equations true. And that's exactly what we're doing. We're taking two linear equations. It's a word problem. It's a real life happening. Gym memberships, a lot of things when you have to join a club, or like you buy a phone. Sure, you bought the phone. Now you want to use it, right? Now we're going to charge you $4 a minute or whatever it is, or like 4 cents a minute, right? So, and this is very applicable. And they say, oh, what's a better deal? Well, this phone is cheaper over here than this phone, but the cheaper phone costs more per minute. The more expensive phone costs less per minute. Eventually, right, they'll cross on the graph, and you're like, oh, at this number of minutes or this number of bowling games, both of these are equal. So I'm going to do one or two more. All right. And I'll put this up, obviously, on my Google Classroom as a video. And you can refer to this when you do the next assignment that I put up, right? Which is just more of this stuff. I think it's fun. I think it's fun because it makes sense. And it's also, you're going to run into this. You know what I mean? Whether it's, it might be, it might be, going to, I don't know, Boost Mobile or Cricket, and finding out, I got to buy a phone, now I got to pay for the charge of the usage of the phone. What's a better deal? And this is how math is applicable in, a real life situation, right? It's not just like some class you take at school and then, you forget it because you're not going to use it. You will use this stuff. And it might be, applicable to like the phone or gym membership, or maybe even a credit card. Sometimes credit cards are like, they charge you money to just get the card. It's, it's a $300 yearly fee to have that card in your wallet. And then it might give you a lower interest rate, where another credit card will be, like, oh, there's no annual fee, but then they charge you more per interest rate. So there's like all these real life situations and scenarios that are applicable to what we're going over today. Okay, so I've got a couple examples. Okay, and now here's a quick and easy one. I'm old, so back in the day, they had this thing called a CD club, all right, where you actually you taped a penny to an envelope and sent it to them, and then they sent you like 12 CDs in the mail, and then you had to start paying for them after that. So you're like, oh, this is great. I got a dozen CDs for a penny. Like literally, that's what they did. And then all of a sudden, and then like, oh, but then you had to keep on buying CDs for like $17. So initially, like, this is great, but then it caught up with you, and then you had to start paying money, like a lot of money, for a CD, where, and that's how they got you. So we're going to say something like, this CD, we'll just call them a CD club, all right? We'll call it like Easy Listeners Club. Okay, to the Rock Out CD Club. And just like we had before, we've got a couple things. We have a y. We have y is equal to mx plus b, right? And we know that slope, cost per unit, I'm sorry, this would just be like the number of units. This would be cost per unit, which is a slope, and then B is the y-intercept, okay? So we're going to do a couple things here. So here, the Easy Listeners Club is, it's $4, per CD, all right? And the Rock Out Club, oh wow, that's a good deal. It's only $2 per CD. So right now you're like, ooh, that looks like a good deal. $2 per CD, $4 per CD. They're both good deals, but one's obviously twice as better. So you'd think, yeah, that's a better deal. But then don't forget, you have the initiation fee, the one-time fixed cost. That will be found on the y-axis somewhere before you even get a CD in the mail. So the Easy Listeners Club is $4 per CD. Ooh, and then $50 to join. $50 to join. And here the Rock Out Club is $2 per CD, but only $30 to join. That seems like a... Okay, so let's see here. I might have gotten this backwards. It should be, let's do this, to tell you the truth. We're going to change this to 50. And this to 30, so I apologize. I made a mistake. So we have $2 per CD and $50 to join. And here it's $4 per CD and $30 to join. Okay, so we're going to have a couple equations, linear equations. So one is y equals 4x plus 30, right? And then this one will be y equals 2x plus 50. Okay, so now we have a couple things happening. You have to ask yourself, what CD club do I want to join? It's like, this is $50 to join, but then only $2 every CD I buy. This is only $30 to join. It's cheaper, but it's $4 a CD. So you kind of have to ask yourself, like if I buy one CD, this is $52. If I buy one CD from the Easy Listeners Club, that's only $34. So right off the bat, you're like, wow, this looks like a better deal. One CD cost me $34, one CD cost me $52. So obviously this is a better deal. And that is true if you're only going to buy one CD. And what we're getting at here is there's two things. There will be a break-even point where it doesn't matter what club you joined. It's going to be the same amount of money if you get so many CDs from both sides, from both clubs. Okay, but then you're going to say, like, you're also, what you're doing is you're predicting, and you're using your math skills to determine, like, no, I like to buy a lot of CDs, or I don't buy that many CDs. And then it'll give you, you'll be able to make an informed decision about, like, what's the better payment plan for you? What's the better club to join? Okay, so the first thing we're going to do is we're going to find out, when are these things equal? And once you find out when these two CD membership clubs are equal, when you find out they're equal, then you'd be like, oh, look, if I buy more than this break even, this club's a better deal. Or if I buy less than this break even, this club's a better deal. So that's what we're going to find out right now. When they break even and what's a better club, depending on how many CDs we plan to buy. Okay, so we do the same thing we did before. We're going to substitute. Here's my y, and I'm going to substitute this, which is y. This y equals this. I'm substitute that for that.
So I'm going to rewrite this entire thing and say 4x plus 30 is equal to 2x plus 50. All right. So what I'll do is, I don't like the negative numbers. So here's, if I took this from that, I'd still have a positive number. So that's what I'm going to do. My x's will be over here, minus 2x minus 2x. Now I have 2x plus 30 equals $50, because that's gone. So then I'm going to do, and I'm going to subtract 30 from both sides, minus 30, and now I have 2x equals 50 minus 30 is 20. I'm going to divide, you have 2 times x, okay? So instead of times, we're going to divide. Instead of multiplication, we divide. That's the inverse operation. Divide both sides by, sorry about that, I'm getting kind of low. Sorry about that. Divide both sides by 2. And then I get x is equal to 20 divided by 2 is 10. Okay, so that's what we think it is. So there's just one thing to do is to make sure our arithmetic is right and that this makes both of these same equations equal. So on plug in I have we have x is 10. So we go to this one right here and we have 4, what's x? It's 10 plus 30. We know that 4 times 10 is 40 plus 30. 4 plus 3 is 7. 40 plus 30 is 70. 70. Okay, so if I buy 10 CDs at the Easy and Lifters Club, it's going to cost me $70. Let's see what's going on over here now. I'm going to clean this up a little bit just so we can tell what's going on. We said x was 10. X equals 10. So let's do this. We had y equals 2x plus 50. So 10. This is y equals 2 times 10 plus 50. 2 times 10. Y equals, what's 2 times 10? It's 20. Plus 50. 20 plus 50 is 70. Y equals 70. So that means that our solution to these two equations would be the coordinate pair of x and y. X is 10. Y is 70. That means that this one starts at 50, this one starts at 30, this one has a steeper slope of 4, this one has not a steep slope of 2, right? And then they'll meet someplace like that, and that would be 10, and that would be 70, okay? So now we know that when you buy, I'm going to clean this up real quick. When you buy 10 CDs from either club, X is 10. X is the number of CDs you buy from this club. Costs you $70. Now from this club, it also costs you $70. So you're going to say, and then we're going to clean this up a little bit. We know X is 10, right? So now, kind of like the end result here is kind of interesting because that is nice to know. And but now it's nice to know where they break even, but it's also even more important so you can make a sound financial decision
and only you know how many CDs you will be buying, right? Or only you will know how many minutes you used last month. And you bring that information into this equation, and then it helps you make a future decision on what phone plan should I buy, what CD club should I join, stuff like that. What gym membership should I join? You know what I mean? If they're charging me like $5 to walk into the gym, every time I go, and I go like 20 times a month, that's going to be expensive, right? So this just helps us make informed decisions on how we spend our money when you're given two plans to decide, and you will be eventually deciding on what credit card you want to carry in your wallet, right? Or what gym you want to join, or even what college you want to go to and how much they cost, and then you have some variables of like, what do they charge you per class? What do they charge you to live in the dorm? Stuff like that. So what we're going to do here is we're going to find out something. We have, we said we had y equals 4x plus 30, and this was y equals 2x plus 50, and we said x is 10. So we said 4 times 10 plus 30, and here we said 2 times 10 plus 50, and we got, this was 70, and this was 70. So now the question is, what happens if I buy one more CD? What's a better deal? So we're going to add 2 to this, plus 2. That's 72. We're going to add 4 to this and get 74. Okay, so you're like, what's that mean? Well, what that means is that if you're going to buy more than 10 CDs, you're only at $72 here. If you're going to buy more than 10 CDs, like 11 CDs, this is 11 CDs. But over here it's $74 for the same amount of CDs. So here comes the big, the information that helps you decide. If you're going to buy less than 10 CDs, so let's subtract a CD from here. So we had 70. And say I'm only going to buy 9 CDs. So 2 times 9 plus 50 would be 18 plus 50 would be 68. And we're going to say 2 times 9 over here. So we said 4 times 9 plus 30. Let's see what happens. 4 times 9 is 36. Plus 30 is 66. Ooh. So this costs more for 9 CDs than this costs. 68 versus 66. So if you're going to buy 9 CDs, this is the better value over here. And then we knew that it's $70 for each membership, okay, for the CD club. And then you're breaking even, okay? But then once we go one more and we buy on the 11th CD, it flip-flops, right? This looked like a better deal, the 66, and it was. At 9 CDs, if you're going to buy 9 CDs, 66 is cheaper than 68. That's a better deal at 9. At 10, 70-70. Now we're breaking even. Now you have an idea of like what a better deal is. You're like, but I like to buy, 12 CDs a month, where I intend to buy 15 CDs this year, right? And so after that, even though it looked cheaper up front because of the 30 versus the 50, that slope of 4, twice the slope of 2, catches up with you. And now I'm spending $74 versus $72. So that's the whole thing, right? We learn that, at one point in time, 10 CDs, they're both the same. 9 CDs. The Easy Listeners Clubs is cheaper at 9 CDs than the Rock Out. But then what happens? You buy the 11th CD, and clearly 72 is cheaper than 74. And then, if you do 12 CDs, this would be 74, and this would be 78, right? This would be 76, and this would be 82. And then it makes it even clearer of which way you should go. And that is pretty much the work I'm asking you to do. There are going to be some questions. What's a better deal? What's the break-even point? When are both equations equal? So you buy the same amount of CDs, and then like here we found out it was 10 CDs and they were totally equal. It didn't matter. But if you bought 9 CDs, I think it was which one? This was cheaper. But then the 11th CD, this is cheaper. So that's what you learn when you deal with like the linear equations and you plug in the formula, and then you can apply this to a lot of real life situations that you're going to encounter from here to eternity, and then you make an informed decision, based on how you perform the math and what you know from your past history of spending, going to the gym, how many classes you're going to take, what the cost of the room and board, like living at the dorm and stuff like that, and then you don't get bills like, oh my gosh, I don't know, I didn't know it was going to be so expensive. I couldn't predict that. This helps you predict, right? You get this linear equation, and then you can predict what's going to be a better deal. And that's really all I have for now. And I'm going to post this on my Google Classroom, so you can check it out if you missed this classroom time, which is fine. You can check this out. This will help you do the work that's due on Friday. Just do the best. Text me, email me, and then have a good day. And hopefully you're going to check out the Pixar meeting we're going to have in about 3 minutes. All right, Math Bridge. Have a good afternoon. Take care. Bye-bye.